Hi, I'm Caroline Richardson, and welcome back to Make the Grade. This is an EOC review program to help you be successful in the EOC. If you haven't already, go to the Wake County website, www.wcpss.net, and go down to the bottom of the screen, and you'll see a link to get you to the EOC review problems for Algebra 1, Algebra 2, and Geometry. And when you have time to do those problems, you can call in. There'll be a number that appears on the screen, or an email for math help that you can email me with questions, and we will try to answer them for you. We'll be here today, this Friday, and next Tuesday to help you answer some questions to help you be successful in the EOC. Now, if you don't have time to do that, there's also a success series out there, which are some videos that are going to help review some of those problems over and over for you again. All right? Well, I'm going to focus today on geometry, our favorite. It'll definitely help you Algebra 2 students with some of the things in the past that you're supposed to remember, some of those formulas that you're supposed to have already embedded in your brain for Algebra 2. And Algebra 1, I'm going to be reviewing some of those skills that you have to know to do geometry, which are Algebra 1 skills, so it certainly won't hurt you to listen as well. Okay? All right, we are going to start with, and these are problems that are very similar to the problems that you'll find on the EOC. These are not the exact problems, but the look and the feel are the same thing. So we wanted to be sure that you could be familiar with what they look like. All right, so let's start with number 1. A right triangle is shown below. Now, one of the first things, and I know this is really going to sound silly, read the question, okay? This is not an essay. This is not War and Peace. This is not something that is going to take you a long time. In fact, if you live on the edge, you probably could read the question 2 or 3 times. Math is made that way. The problem is very short, very sweet, but everything that's in it is very important. First thing that's important right now is the right triangle. As soon as you hear right triangle, I need you to start thinking Pythagorean theorem, special triangles like 30, 60, 90, 45, 45, 90, or your trig, your cosine, sine, and tangent. Think of your functions, okay? All right, as we look at this one, it says it's a right triangle below, and here's the right angle already marked. What's the approximate value of x? So x in this case is an angle. We're trying to find an angle, and we need to look to see what other information is there. Well, most of the time when they're trying to get you to find an angle, there's one of 2 routes you can go. You can look to see if you know the other angles and subtract from 180, because you know the sum of all the interior angles is 180. In this case, we have no idea what this third angle is. We know this one's 90. So the second choice is normally trig. Okay, now don't be scared about that. It's just your ratios. We need to remember some of our functions, and the best way to remember it, hopefully you have learned SOHCAHTOA, or some sort of shortcut that'll help you remember. In this case, we're trying to find x, and we look at the information that we have. We have the information opposite the x, and we have the hypotenuse. Take a second and mark your information. That's where most of your careless errors are going to come from, is that you've mixed up some of your information. All right, which trig function is going to use the information with opposite and hypotenuse? Well, the sine function. The sine of an angle is equal to the opposite over the hypotenuse. It's just a ratio. All right, the sine of what angle? Well, in our case, the angle x. So the sine of x is equal to the opposite, which is 8, over the hypotenuse, which is 30. Now, in this case, we're trying to find an angle, so you can't just type into your calculator sine of x. It's not just going to come up with some mystery value. You also just can't type in the sine of 8/30ths. It's not going to work as well. So what you need to think of this is almost, you know when you solve for x sometimes and you have to get the other information to the other side, you do an inverse function. If it's multiplication, you do division. If it's addition, you do subtraction. Well, we're going to do the same type of thing with a trig function. The inverse function would be the inverse sine of, in this case, 8/30 equals x. Okay? So quick reminder, the sine of an angle equals a ratio. The inverse sine of a ratio equals the measure of the angle. Okay? Remember that, and that's true for cosine, tangent as well. Okay? So we're going to type this into the calculator. I'm over here on the calculator, and there's a couple things I want to remind you. If you haven't seen me before, I think I keep harping on this. When you first reset the calculator, one of the things that's going to happen, and it's not on this one because I've already been playing with it, is the default is going to be radians. It should be blinking there on your screen. So most of you don't know what radians are just with the level math that you're at right now, or you might know what they are, but you haven't dealt with them in geometry. So you want to be sure that you go down and you change the value to degrees by highlighting it and hit enter. Once you're in the right mode for taking the test, which would be in this case degrees, now we can go ahead and solve the problem. So to solve it, you're going to hit second sine, You see that sign, little -1, that's inverse sine. In this case, the ratio is 8/30, which is equal to, and back up here, it has that x is approximately 15.5, and if we look at our answers, 15.5. Now, where are these other answers coming from? Well, some rounding issues could come up, or if you didn't convert your radians, you might be getting one of these answers, or they're also accidentally you solved for one of the other angles. That would be its complement, wouldn't it? So you have to be very careful for what you're solving for. All right, let's look at problem 2. A dead tree was struck by lightning, causing it to fall over at a point 10 feet up from the base of a tree. Okay, you may be looking at this saying, why do I care? Well, the point of this problem is several things. I haven't finished reading it, first of all, but can you all see, oops, let me get my pen open. Can you all see that as soon as the tree tipped over, a triangle was formed? And one of the rules of thumb is that the tree is perpendicular to the ground, meaning it formed a right angle. A flagpole is perpendicular to the ground. A building is perpendicular to the ground. It may not be true. You've seen trees that are bent a little bit. But for our purposes, when we're doing math, we always assume that the tree, the flagpole, the building, whatever it might be, is perpendicular to the ground. So it makes a right angle. So right here I have a right triangle. This problem is really not about the tree. It's about a right triangle. Okay? Next thing, if I read the rest of the problem, it says the fallen treetop forms a 40-degree angle with the ground. About how tall was the tree originally? So you know what? I'm going to underline the part that I'm looking for. How tall was the tree originally? We want to keep that always at the front of our mind, what it is we're looking for. All right, so I have a triangle. I'm going to pull another piece of paper in here because I want to redraw the triangle. Because I really don't want to look at the tree. I just want to deal with the mathematics of it. We'll come back to the tree in a minute. What do we know? We know that a dead tree was struck by lightning, causing it to fall over at a point 10 feet up from the base. So this information is 10 feet. The next thing is that it told us that when the tree fell, it fell at a 40-degree angle. So this angle right here is 40 degrees with the ground. Okay? And the next thing it's asking us is, how tall was the tree originally? So that is, how tall was the tree before it fell over? Well, for us to find that information, this part right here is the part where it fell over. So we need to find that information. Well, that information happens to be the hypotenuse. So I'm just going to label that x for now. So if we can find the length of the hypotenuse, so where the tree tipped over, and then stand it back up and add it all together, we'll find the length, the whole total height of the tree. Okay? So now let's just focus on the triangle. Forget the fact that there's a tree there. We are trying to find this information x. What information do we have? Well, we have this angle. We have the information opposite the angle. We have the hypotenuse. Which one of our trig functions deals with opposite and hypotenuse? I wrote that down a second ago. Sine deals with opposite and hypotenuse. Okay? Sine of what? Well, the sine of an angle equals the opposite over hypotenuse. I'm real big about writing down the recipe. Get the geometry organized, then focus in on the algebra or the arithmetic. Just get those rules straight. Don't try to rush and start doing algebra before you've gotten your 1 rule or 2 rules straight from geometry. All right, the sine of what angle? The sine of 40 degrees is equal to its opposite, which is 10, over the hypotenuse, which is x. We're going to use some of our laws of proportions, and I'm going to switch those. So x is equal to 10 over the sine of 40 degrees. Now, we don't do inverse sine here. Remember I said that the sine of an angle is equal to the ratio. Inverse sine of a ratio is equal to an angle. What are we trying to find? Well, we know the angle, so we're going to just use regular sine in this case. All right, so let me type this into the calculator. So 10 divided by the sine of 40. And I always close my parentheses. It's a good habit for later on. It won't affect you in this particular problem, but it's a good habit. Is equal to, x is equal to 15.6. Okay? So let's come back over to our answers. Oh, this is so exciting. Look. They rounded all their answers to whole numbers, so x equals 16. So the answer must be B, right? Nah. This is a sucker problem, okay? Lollipop, lollipop, oh, lollipop, lollipop. Okay? They've tricked you. You have to remember what the original question was. Look, at 16 is here. This is a stage of the problem that you're at, and 16 is here, but that's not the answer. The question was, how tall was the tree originally? What you just found was the part where the tree tipped over was 16 feet long. Now we need to find out how tall was the original tree. So if we glue it back together, that's 16 feet and 10 feet. How tall was the tree? 26 feet, okay? The geometry is notorious for putting little lollipop questions on there, if you will, just because you get so excited that you solve the algebra, but you have to go back and finish the geometry, okay? And this is the first of many like this. Every time a problem comes up like this, I'm going to draw this little lollipop so you can remember, okay? All right. Let's look at problem 3. What is the area of the trapezoid? Hopefully, we remember what a trapezoid is. Trapezoid is a shape where there's one set of parallel lines versus two sets of parallel lines, which would be a parallelogram, or no sets of parallel lines, which might be a kite or another type of quadrilateral. So we want to find the area of a trapezoid. There's several formulas you're going to need to know. You just need to know them. I'm not going to give you. You're not going to be able to turn to the back of your test booklet and find any formulas back there now. You need to know these. You know this one. And if you forget, I'll give you a hint. If you have a trapezoid, if you think about it, a trapezoid is nothing more than a decapitated triangle. Okay? They just cut the top off. And the area of a triangle, you've known for a long time. It's 1/2 base times height. Okay, so we cut the head off, which that sounded terrible, but we cut that off. And now what's happened? Well, now we have two bases. Well, it turns out almost everything that happens with a triangle you can almost do with a trapezoid. You just have to throw in the second base. So the area of the trapezoid is equal to 1/2 base 1 plus base 2 times height. Okay? So that's just a trick to remember. And I'm sure all of you have memorized that, but sometimes in the panic of the test you forget. All right. So here's my recipe. So let's look at what ingredients I need. I need base 1, base 2, and height. Okay? This is not taking much time to write this down, is it? Base 1. Base 1 is 12 centimeters. Base 2 is this value. Down here at the bottom, I don't know that. Height, I don't know as well. That's this length right here, this height right here. So there's two pieces I don't know. So what can we do to solve it? Well, one of the nice things about a trapezoid is that you can cut a trapezoid up into a rectangle and triangles, okay? Or triangle, depending on the trapezoid. So if I cut this and make a rectangle, and we know, based on the markings, that it's isosceles, those two legs are congruent. So when I cut it here, I ended up with a 12 and a 12, top and bottom, and then two little pieces left over, okay? So if I can figure out what this little piece is, right here under the 60, then that'll help me find the whole length of the bottom base. Okay, so can you see that that's 60, and that 60 belongs to this angle right here. Sometimes that's tricky on the picture, so I'm going to enlarge it for your viewing pleasure. The 60 belongs here. I know that's 12, that's 12. I'm trying to find this little value. Now, when you draw a height, heights are always perpendicular to their base, correct? I see you all nodding. You're right. Okay, so they're perpendicular to the base. That means I have what type of triangle? Right triangle. What am I thinking? I'm thinking Pythagorean theorem. I'm thinking 30, 60, 90s, 45, 45, 90s, trig, all kinds of things. Well, since these were marked congruent and this one was 8, the length of this side is 8. So I don't have enough information to do Pythagorean theorem, but look, I've got the 60. 30, 60, 90 triangles. Now, if you can't remember the shortcut, you can always do the trig. It'll still work, okay? But the shortcut happens to be that if you have a short leg of a 30, 60, 90 triangle, and how do we know it's the short leg? Across from the smallest angle is the smallest leg. Across from the widest angle is the longest leg. So in this case, across from the 30, that's the value we're looking for. That's the short leg. The hypotenuse is equal to 2 times the short leg. And the long leg is equal to the short leg times radical 3. Okay? I always remember the radical 3 because 30, 60, 90, all divisible by 3 always seems to trigger it for me. So I'm trying to find the short leg, which happens to be x in this case. And what information do I know? I know the hypotenuse. So we can look here. The hypotenuse is 2 times the short leg, which means the value of this value of x is 4. I'm cutting these identically, so this value over here is also 4. So what's the length of our entire base 2? Not 8. You have to add the 12 in there. So 12 and 4 and 4 would be 20. And we still don't know the height. We have to find this value. Well, now we're to the point where we could do Pythagorean theorem, right? Because you have two sides of a right triangle, and you can find the third. Since I'm working with a 30, 60, 90, I'm going to go ahead and finish this off. And it says to find the long leg, which is across from the 60-degree angle, versus the hypotenuse, which is across from the right angle. I'm going to take the short leg times radical 3. Well, the short leg was 4 times radical 3. Done. 4 radical 3. So I have a recipe. I have all my ingredients. So now I can start cooking. Okay? Get it? Okay. So 1/2 base 1 is 12 plus base 2 is 20 times the height, which is 4 radical 3. 1/2 of 32 times 4 radical 3. Half of 32 is 16 times 4 radical 3. Now, at this point, you need to look at some of your answers. If I multiply this out, you can get two possible answers. You can get an exact answer. Oops, exact. Exact? Whew, it's so why I majored in math. Okay, exact abbreviation is equal to 64 radical 3. You multiply outsides times outsides, and there's no other radicals. That's an exact answer. However, if you look at the answers that they're offering you on the EOC, those are decimals, which means you're going to find an approximation. So if we go to the calculator, we can go ahead and type in 64 times radical 3 is equal to, back up here, 110.85, so 110.9, which happens to be B. And I didn't mean to imply that math people can't spell. I just happen to be a poor speller, so I'll work on that for you. Okay? All right, wonderful. So things we have to remember. Some of the issues with triangles are going to come up. You need to remember your formulas. You need to make a whole list of the formulas you need. I'm sure your teachers have given you that. You need to know them. There's going to be no other hints on the test for you. Okay? All right. Let's look at the next one. All right. An inflated round balloon with a radius of r equals 50 centimeters holds approximately 523,600 cubic centimeters of air. Whew. When the balloon is contracted so that the radius is 2/3 the original size, what is the approximate volume of the partially deflated balloon? Okay. So some vocabulary in here. First, we need to understand what type of shape we're talking about. In this case, we're talking about a sphere. Okay. So you can, I get a piece of paper. You can draw that. Gosh, I wish we had some tools that we could draw it, because the more accurate you draw, the better off your answers are. Well, as a matter of fact, when you get your test booklet and the teacher is asking for your name and handing out materials and you're bubbling things in, they're also going to give you graph paper. Now, it's not going to be this exact paper, this exact graph paper. This is probably something you're familiar with, but they'll give you kind of a black and white, a little bit bigger block sort of graph paper. It doesn't matter. Get several pieces of it, okay? And I want you to take one of those pieces and I want you to fold it. Now, I'm going to cut this in half to make it not quite so thick. And you can do this. There is no rule in the EOC that says you can't rip and fold paper, okay? So here we go. I've taken a piece of graph paper and I have folded it. Why is that so exciting? Well, one of the things it does for you is it gives you a straight edge, okay? So I can take this, and I probably should have folded this a little sooner. Hold on. I can take this, I can put it next to it, and what have I created? Well, there's an equal distance between two lines, so I automatically have parallel lines. I can draw the transversal through them. If they give you a picture and describe it, you want to be able to draw it as accurately as possible, okay? One of the other things it's also done for you is it's created a ruler. What if they told you that you had to draw a segment that was 5 centimeters long? Well, this might not be centimeters, 1, 2, 3, 4, 5, but it is calibrated to be 5 units, okay? So you could give that illusion that it's been calibrated for 5, okay? 5 centimeters, 5 inches, 5 feet. That could be 5 miles. It doesn't matter, but it's equally been cut. So this ruler has not only given you a straight edge, but it's also given you a calibrated straight edge, which is a ruler. The other nice thing is, and hopefully, let's see if I can do it with these pens, you're going to have number 2 pencils. Number 2 pencils have pretty hard lead. Let's see if I can get through on this. Don't want to mess up my one color I like. Oh, here we go. If you bring one of the number 2 pencils that has the clicky kind, okay, that has a nice hard tip, okay, those are number 2 pencils. See how I poked right through that? Okay, I'm going to do that there. And I'm just going to pick another random spot. And while the teacher's talking and asking you, do you have your number 2 pencils and do you have all your paper, and please be sure you're bubbled, and she's telling you the rules and you're getting ready to do practice sample question 1, you can be doing this. How does this help you? Well, you're supposed to have 2 number 2 pencils at all times, right? If you don't, you're supposed to raise your hand and be sure you have one. I can put one pencil at one spot, one pencil at another spot, and shazam, I have a perfect circle, okay? How is that going to help you? Well, the more accurate your drawings. Everything in a circle seems to work out pretty. Well, if you can draw a pretty circle, I guarantee if you draw some of the values in there, the way they've asked you to do them, depending on the problem, and they said that there's 2 chords that are equal in length. Look at that. There's 2 chords equal in length. You can almost see that they're the same. And you can see that if you draw the radius to it, that it makes a right angle. It'll help trigger some memories for you, okay? So this can be a pretty powerful tool. It can be a compass, make those circles. You also have a right angle going on here, okay? If you want to fold it so it's a tighter right angle, we can do that. You have a right angle. If you need to draw a right triangle, there it is, okay? So the more accurate you are, the better it is. This is one of those tests or one of these courses that you've been taking all year, that you've been using tools, but when you get to the EOC, there are no tools for you to use except the graph paper and the plain white paper. Use it, okay? Ask for as many pieces as you want. All right, and the moral to that story was I needed to draw a sphere. So I'm going to take this, and if everything's all done, it's not going to take that long in your paper, right? And you have plain paper. I'm going to draw a sphere. Oh, I bent my little tip. It's okay. And hopefully you've practiced all year so you know how to draw and envision these. So there's my balloon. And the balloon has a radius of 50. Centimeters, and we know that it has an approximate volume. It holds 523,600 cubic centimeters of air. So another magic formula that you have to remember is the volume of a sphere. Volume of a sphere is equal to 4/3 pi r cubed. How do I know that? Well, I've memorized that. You've derived it throughout your year, and hopefully you've memorized it as well. Okay? And some information that we know, well, we actually already know the volume of the sphere at this point. That was some information that they gave us. Another piece of information in the recipe is the radius equals 50. Okay? Well, that's not really the question. The question now boils down to is when the balloon is contracted so that the radius is 2/3 the original size. So this new radius is 2/3 its original size. So what is 2/3 of 50? 100/3. That's fine. That's a nice exact answer for now. Okay? So when the radius is 100/3, now what's the volume of the sphere? So the volume of the sphere is equal to 4/3 times pi times the radius, which in this new radius is 100/3 cubed. If I type that into my calculator, I have 4/3 times pi times 100/3 raised to the 3rd power is equal to the volume. The new volume is equal to 155,140.378. Okay, so now we're going to look at our answers. And oh my goodness, there's not one of those answers that's on there. So do you panic and say you did the problem wrong? Well, sometimes. But actually, if you look a little bit closer, you're going to notice that these answers are in scientific notation. So you can take your answer that you came up with it and convert it to scientific notation, or you could take each one of these answers and convert it. If I had to pick one to start with, I think I would choose B to start with. Why? Because you see how this one has 155 at the beginning and this has a 155 there? So if we were to do scientific notation, what is that? You take the decimal and you move it. If we're going to convert to scientific notation, you move the decimal to the left until it's a number that is less than 10. So we move it. Move it to the left. So 1, 2, 3, 4, 5. So we're left with 1.55140. The decimal's gone. Sorry. 378 times 10 to the. Well, when you divide by 10, how many times did we? If we're going to convert back, sorry. 10 to the what power is how many times you move that decimal. So we moved it 1, 2, 3, 4, 5 times. 10 to the 5th power. Well, they've rounded this one, so that's okay. So approximately 1.55 times 10 to the 5th. There you go. It's part B. Okay, so don't panic. Take a second to analyze your answers a little bit. All right, great. All right, the next problem is dealing with probability. Probability can be tricky sometimes. Sometimes it's just a matter of thinking it out logically. You need to go back to some of your middle school math, and you need to go back to some of your Algebra 1 math, and of course what you were taught in geometry to remember what probability is. A point is randomly selected on segment XY. What is the probability that it will be closer to the midpoint of XY than to either point X or point Y? Well, let's try to visualize it. Here we have segment XY. Do you know what a midpoint is? You better be bobbing your head that you know what a midpoint is. A midpoint, trickily named middle point. Okay, mathematicians aren't creative when it comes to vocabulary. It's the middle point. Okay, so I'm just going to call it M. It's the midpoint. So the question is if you close your eyes, and I guarantee you're going to touch this line. I did, thank goodness. I guarantee that you're going to touch this line if you close your eyes and point to it with your finger. What are the chances that you're going to be closer to the M? Okay. Well, if this was money, and I said, I'm going to let you reach into a bag and pull out some money, and what are the chances that you're going to be closest to $50? When aren't you closest to $50? Well, there comes a time when, after about $25, like $25.01, that you're closer to $50 than if you were under $25. And there comes a point after $75, if you will, that you're closer to the $100 mark. Okay, and I'm not talking pure rounding rules. We're just talking being close to that $50 mark, okay? So if I'm going to be close to this midpoint, I would need to hit somewhere in this range, because hitting anywhere in that range will be closer to point M than it will be to point X or Y, okay? So in terms of probability, well, how many total segments are there? There's 1, 2, 3, 4 total segments. Out of those 4 segments, which ones do I want to land on? I want to land on one of these 2. So 2 out of the 4, which reduces to 1 out of 2. There's a 1 out of 2 chance that I will hit a point closer to the M. Okay? So is that a good bet to make? Well, it's 50-50, right? So you'd have to decide. All right, number 6. I like problem number 6. And you know why? You're going to know in a minute because I'm going to sing to you. Just remember I told you that, so be prepared with your volume. Okay? Let's look at this problem. To win a carnival game, Keisha must throw a dart at a board that is 4 feet by 3 feet and hit one of the 25 circles on the board. The diameter of each circle is 4 inches. Okay, so they've drawn the board 4 feet by 3 feet. Approximately what percent of the time will a randomly thrown dart that hits the board also hit a circle? Okay, so here you are. You've gone up and you paid your $1. They gave you 3 darts. Poof, poof, poof. You're going to throw and pop a balloon, right? What are the chances that you're really going to hit one of those balloons? Okay, so you can mathematically win at the carnival now. All right, first you have to remember probability of an area of space. Probability for area is equal to the area that you want divided by the area of what you have. Okay? The area which we want in this case is to hit one of those balloons. So how many balloons are there? Well, there are 25 of them. 25 times the area of the circles. Okay, that's one of the areas that we want to hit, divided by the area of what we have. Well, the area of what we have is the region we're guaranteed the dart's going to hit somewhere on that board. Okay, it's not going to hit the guy sitting off to the side. We're not going to throw it to the ground. It's going to hit the board. So it's going to hit this region, which is a rectangle. So the area of a rectangle. Okay. What are my recipes? Well, the area of a circle is equal to pi r squared. Do we know the radius? Let's see if we have the ingredients. We know pi. That's in our calculator. We know our radius of each diameter of the circle is 4 inches. Right, 4 inches. So if the diameter is 4 inches, then that means the radius is, good, 2. So radius is equal to 2. So I have all my ingredients. So pi 2 squared is equal to 4 pi. And I'm just going to leave it like that for a minute. Okay, so I finished that part of it. Next thing, I need the area of a rectangle. Okay, and this is the part that got me. So I'm going to let you just do this problem and let's see if you can figure it out. The area of a rectangle is equal to length times width. In this case, they told us that it was 4 feet by 3 feet, right? So we're going to say 3 times 4, which is 12. Looks good so far, right? All right, so now we're going to put these back into our problem. 25 times the area of the circle, which was 4 pi, divided by the area of the rectangle, which was 12. We type that into the calculator. 25 times 4 times pi, that answer divided by 12 equals 26.2. And look at our answers. B. Isn't that beautiful? Rounded to 26%. But guess what? Lollipop, lollipop, oh, lolly, lollipop, lollipop. They got you again. They got me the first time they did this one. You know why? Units. If one of the problems goes out of their way to talk about units, see how they said feet, inches? If there's different kinds of units going on in the problem, then you can almost guarantee, I would say 95%, I'm just making that number up, but it happens almost every time. And it happened to me, and I've only been doing math for maybe a year or 20 some odd years. But it got me on this one. You have to look at the units, okay? If you're going to do probability, just like if you were going to do ratio and proportions, you want everything to be in the same unit so that you can compare them equally. You can find a proportion, or you can, in this case, a percentage or a probability that is all related to each other. So we need to convert the 4 feet and the 3 feet to inches before we can move on because our circle was in inches. Now, if you wanted to, I suppose you could convert your inches to some fraction of a foot. That just gets a little bit uglier. I think it'd be easier to convert our feet to inches, okay? So even though this recipe was correct, not quite right, okay? So we need to take the length, which is 3 feet, multiply it times 12, and get 36 inches, and our width, which is 4 feet, and multiply it times 12, which is 48 inches. Now, if we put this into our recipe, that's 36 times 48, which is 1,728. Now, let's put that into our recipe. Do that in blue so you can see this is the correct one. So 25 times 4 times pi, divided by the area of the rectangle, which this is the correct area of the rectangle, 1728. Type this into the calculator. So 25 times 4 times pi, that answer divided by, oops, not 12, divided by 1728 equals. Now, I want you to look at the screen in terms of my answers. Now, you can't quite see me pointing, but the one that I came up with just now is 0.1818, blah, blah, blah. The one I came up before was 26 point, and if I round it, 6. Even though the answer 26 was on there, it's really not in terms of what we need. Back up here on the screen, I'll make that make more sense. This one worked out to be 0.1818, so it rounds. We'll stop at 0.18. This is the decimal. How do you convert a decimal to a percentage? Well, to convert a decimal to a percentage, you're going to move the decimal twice to the right, okay, like times 100. So we'll move it twice to the right. That's 18%. If we had taken the time to even analyze our other question before we circled, the answer that came up in the calculator was 26, rounded, 26, right? If we convert 26 to a percent, we move the decimal twice, that's 2,600%. And that answer definitely wasn't on there, okay? So even if we had a lollipop answer going on over here, if we'd finished the problem using the rest of the math, which was converting decimals to percents, we have to move it. There's a decimal in a 26 decimal, right? Just because it's not there, it's always there. So our real final answer on this one is 18%. All right, awesome. Hope that helps. I guarantee, lollipop, while you're studying for EOC, eat some. Or pretend you are. Put an apple on a stick. All right, this one is dealing with goal 2, which I need to find to read off to you, but goal 2 is a bulk of what you learned. It's the logic, it's all your shapes. It's the bulk of what you learned in your class. There's an awful lot of questions on there, but there's just as many questions that are going to come from some of your other goals, okay? Just the bulk of the material from goal 2 is the bulk of the material you learned in class. Is this the goal? Here we go. Well, this will give you a rough idea. Objective, stop peeking at those answers. Look at you. All right, objective 2.01, use logic and deductive reasoning to draw conclusions about problems. That kind of continues down here. Apply properties, definitions and theorems of angles and lines to solve problems. Here, apply properties and definitions and theorems of two-dimensional figures. Okay, so quadrilaterals, triangles, circles, other polygons. That's pretty much all the shapes that you worked with, right? Okay. What it's missing is a lot of those algebra concepts you did, some of the coordinate information, some of the matrices that you did towards the end maybe, or in the middle with transformations, and the information that I just went over with the probability. That's what was missing. Okay, number 1. Conditional statement. All 45-degree angles are acute is true, okay? Even if they told you all cows are purple, if they tell you the statement and it's true, you need to go with it, okay? So in this case, it actually is a true statement as well as they've told you it's true. All 45-degree angles are acute angles is true. Based on the conditional statement, which of the following can be concluded from the additional statement, the measure of angle A is 45 degrees. Well, you may have seen this in some of the work you were doing, and that is they have, and I'm going to write this in conditional format, if an angle is 45 degrees, then it is an acute angle. And I'm going to label the hypotenuse, or not hypotenuse, the hypothesis as A and the conclusion as B. Okay? So what did they tell you? They told you A implies B, and they told you that was a true statement. Now, if your original statement is true, you can only deduce one or two things from your original true statement. You can deduce the original concept again. Okay? So if somebody says, in this case, I'll just use this one. If A is 45, or an angle is 45 degrees, then it is acute. And I said, oh, look, by the way, that's 45 degrees. And you're going to go, it's acute, because you just repeated the original statement. The other piece of information that's going to be true is the contrapositive. That's where you flip your hypotenuse and conclusion, or darn it, it's twice. Flip your hypothesis and conclusion, and you negate both of them. That'll be true. Now, you can draw conclusions based on your other logic, your converse and your inverse statements, but sometimes that logic is flawed. Okay? So the only true conclusions come from the original statement and the contrapositive. So in this case, they told us this original condition, and then they told us the measure of angle A is 45 degrees. They basically told us part A again, didn't they? That's just in more detail. They just told you that, well, this measure A, this angle happens to be 45. Okay, well, then what can you conclude? Well, if A implies B and they tell you A, then the only thing you can conclude is B again. It's just in this case more detail. So you would conclude that angle A, oops, capital A here, angle A is an acute angle. I will say when it comes to the logic questions, try to do the logic off to the side before you look at some of your answers, because logic can be tricky. You remember when you learned it, it was, it felt like you were constantly being convinced of something just based on whether the if came first or the then, or they switched it. It gets very confusing sometimes. Try to do the work off to the side, even though it's not mathematical. It is, it is mathematical, but it's not algebraic, let's say, with your numbers. But do this logic off to the side, and then come back and look at your answers. The complement of A is not an acute angle. It might be true, but that's not following the rules that you just came up with. What are we looking for? Angle A is an acute angle. There it is, part C. I guarantee if you look at your words first, you're going to be able to find one of those that work. And a prime example of that is, you remember the day you discovered answers in the back of your book, back of your math book? It was a great day, wasn't it? Because you just wanted your teacher to give you the odd problems or the even problems, whatever was back there. And if the answer to the question was 5, I guarantee, no matter what the problem was, you could do some sort of math to get to 5, couldn't you? Oh, yeah, that was great. Math is very good that way. If you look at the answers, you can get to any answer. Okay, so this is just a hint that I want you to try to do the logic before you look at your answers. All right, problem 2. Problem 2 says triangle MNO is shown below. Okay? Now they've shown us a triangle and they've given us sides and they've labeled the angles. Which statement is true about this triangle? Now, in general, I just want you to look at the answers to see what type of question, because there could be an awful lot you could say about this triangle based on the information that's here. Okay? But specifically, it looks like they're trying to order the angles in terms of their measure. So you need to look at this triangle now and go ahead and order the angles in terms of their measure before you try to answer it. Well, what's the general rule? The general rule is across from the smallest angle is the shortest side. Across from the largest angle is the longest side. And that makes sense. If you have to open an angle, the side across from it's going to be pretty big, right? So let's take this a second and look at this triangle. 12 is the shortest side, which means angle O is the smallest angle. Okay? So angle O. And then 25 is the next smallest side. Across from that is angle N, so O is less than N. And then 28 is the longest side, so across from that is going to be the largest angle. Even though it might not look that way, oops, hold on. Even though just looking at the picture it might not look that way, that's not what we're basing this on. We're basing it on the facts and the theorem that you learned, that across from the shortest side is the smallest angle, and the converse of that is also true. All right, so this is the order. O is less than N is less than M. And of course, I'm talking about their measures. I'm not talking about the physical angle here. Which statement is true about this triangle? The measure of O is greater than M. Okay, well, this one is in greater than format, so let's switch these around. M is greater than M is greater than O. Okay, so is O greater than M? No, it's not. A is gone. Is the measure of M greater than N? Yes, it is. M is greater than N. That one works. Okay, now there's only going to be one correct answer, but for you doubting Thomases, let's keep going. M is less than angle N, so M is less than M, no. And N is less than O, see? O is less than N. You got to be sure you know your basic inequalities, right? N is greater than O, so that one didn't work. So for sure, B did work, okay? Okay. What is the contrapositive of the statement below? It's logic. Don't look at the answers, okay? If the triangle is isosceles, then it has two congruent sides. So, if P, then Q. That's the original statement. What would be the contrapositive? If not Q, then not P, okay? So what is P in this case? The hypothesis is a triangle is isosceles, so I'll call that P. Then it has two congruent angles. We'll call that Q. So we're going to flip those two in terms of order, and we're going to negate them. So if a triangle does not, it's as simple as that, does not have two congruent sides, then it is not isosceles. Okay? That's the one we're looking for. I guarantee if you look at all these answers, you're going to be like, oh my goodness, I don't know what's going on. So we're looking for if the triangle does not have two congruent sides. If a triangle does not have two congruent sides, there it is, then it is not isosceles. There's our answer, first one. If we look at the other ones, if a triangle is isosceles, then it does not have two congruent sides. That was the statement, if P, then not Q. That's not even one of your choices in terms of our converse-inverse world. If a triangle has two congruent sides, then it is isosceles. That would be if Q, then P. That's the converse. And D, if a triangle is not isosceles, then it does not have two congruent sides. That's if not P, then not Q, and that would be your inverse. Okay, so your other choices were there. Things that you're familiar with learning are there. You just have to make sure you get your rules straight. Focus on the geometry, and in this case, get the words straight, then look at your answers. Even though it took me a few minutes to talk this out with you, it's not going to take you that long on the test. And these ones in the very beginning, these are some of your easier problems, I think, that you really want to be sure that you get correct. Okay? Well, you want to make sure they're all correct. But. Okay. Let's look at number 4. Number 4. First look looks like stairs to me. So let's read the problem. Told you that K is parallel to M is parallel to N. Now, this just looks like stairs. So what I'm going to do is I'm going to take my little cheaty ruler here, and I'm going to extend this so they look like parallel lines to me. And in fact, it's still attached to the staircase. So even though you're probably shaking your head going, I can't believe you would do that, I would probably off to the side redraw the lines. And my transversal in this case, T. There's several transversals there, but the transversal that goes through all three of them is T. So here's K, here's M, here's N. They're all parallel to each other. Mark it, mark it, mark it. And then it gave us some information about angle 1. So K in relation to the transversal, here's angle 1. And then it told us something about angle 2, angle 3. Well, even if I just look at one set of them, what's the relationship between angles 1 and 2? Well, as soon as you hear parallel lines, I want something to start rolling through your head. As soon as you hear parallel lines, lines are parallel, I want you to hear alternate interior angles are congruent. Alternate exterior angles congruent. Corresponding angles congruent. Same side interior angles supplementary. Okay, just boom, boom, boom. You've got to just roll through those 4 things. What type of angles are these? Well, these 2 angles happen to be corresponding angles. What do we know about? If lines are parallel, corresponding angles are congruent. If lines are parallel and are cut by a transversal, then alternate interior angles are congruent. That's a true statement, but that has nothing to do with angles 1, 2, and 3 in this page. Okay? If the 3 lines are parallel and cut by a transversal, then vertical angles are congruent. Well, you know what? Vertical angles have nothing to do with lines being parallel. They just have to do with lines intersecting. Anytime lines intersect, vertical angles are congruent. So that's a part truth. Vertical angles are congruent. It really doesn't have anything to do with the parallel lines. If parallel lines are cut by a transversal, then alternate exterior angles are congruent. True statement. That is so true. But that's not the type of angles we have. And finally, if K, M, and N are parallel and cut by transversal T, then corresponding angles are congruent. Bing, 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 bing. The most important part of this is that K, M, and N are parallel. Because you know what? I can draw 3 lines, call them K, M, and N, cut them by transversal T, and this angle 1, and this angle 2, and this angle 3 are still corresponding angles. But you know what? They're not congruent. Corresponding angles exist by definition. Alternate interior angles exist by definition. Vertical angles, alternate exterior angles, they all exist by definition. But when you fine-tune it and say the lines are parallel, then they become congruent or supplementary or whatever it might be. So be very, very careful that you read your directions. If you didn't read this given, then you couldn't draw that safe conclusion. Okay? So watch for that. How are we doing on time? Okay. All right, I've got time to do a few more. Let's look at number 5. In the drawing, what is the measure of angle Y? Okay, so I'm trying to find this angle right here. Looks like a right angle? Might be. You can't go by visuals on this. Okay, we don't know who drew this and how it was drawn. You can only go by the information that was given to you. You can go by the position that things are in. Like, we can definitely see that V, T, and whatever this mystery point here make a triangle. That's okay, but we don't know what kind of triangle, right? All right, so we need to try to break this down to some information. Well, X marks the spot for what? Vertical angles, right? So if angle 40 and angle X are vertical angles, what do you know? Well, if two angles are vertical, then they are congruent. So the measure of angle X is 40 degrees. Circle A! No, I got you again, okay? You're going to be so excited that you found an answer that matched. You're going to start bubbling and circling. Stop a second. See how at the very beginning I went ahead and kind of you're allowed to have a highlighter. Go ahead and highlight the Y so you know what you're looking for. Circle it in the problem. I'm looking for angle Y, okay? Giant arrow, neon lights, I don't care. Make sure that you know what it is you're looking for, okay? Because they're going to have the other answers there, and that's what you don't want to get tricked up on. All right, so it's not angle A. Let's keep going on with the problem. Now we have this triangle. We're trying to get up to angle Y, so I'm going to look at this triangle now. We know that the sum of the measures of the interior angles of a triangle are what? 180, good job, which means the measure of angle X, in this case 40, and 60, and angle, I'll just call this one Z. So we have a little Z. Here, we'll call it P. All right, so this angle P right here, what's the measure of its angle? Well, we have 40 and 60, so that's 100. 180 minus 100 is 80, so this angle right here, which I've kind of messed up there, is 80 degrees. Look, there it is. No, that wasn't the question, okay? Well, aren't 80 and Y the same angle? No, vertical angles are congruent, so this angle over here is also 80. What is the relationship between angle 80 and angle Y? Well, you can also use your cheaty ruler, because look, what do they make? They make a line, okay? And I could redraw that over here and just pull out the information I want, which is angle 80 and angle Y, okay? So I just took out all the other information that I don't need. I'm just focusing on what I want. What can you say about angle 80 and angle Y? Well, they're linear pairs. And what do you know about linear pairs? They're supplementary. So that's gone. What's the supplement to 80? 100 degrees. So the measure of angle Y is 100 degrees, okay? This was a two lollipopper. Look at that. They could have gotten you twice. This is what I do to my students all day, okay? All right, be very, very careful, because that one could have gotten you twice. All right, let's keep going. Proofs. Yay, we love proofs. You actually won't see too many problems. Who knows actually what's going to be on there in terms of the quantity. But the types of problems that you're going to see when it comes to proofs are problems that everyone in the state of North Carolina would be familiar with, okay? So it's not going to be, most of the time, I can't guarantee this, but it's not normally going to be a theorem, the very tiniest, littlest theorem that is very obscure that you might have proven in class if you had extra time. It's going to be some of those major concepts that you took a lot of time to focus on. Think about it. You took a lot of time on dealing with angle addition and some segment addition and angle addition. You should have taken a lot of time to deal with how to prove lines parallel. You should have taken a lot of time to prove how triangles are congruent. You might have taken a lot of time to deal with how to prove quadrilaterals or parallelograms, or those parallelograms are rectangles and squares. And then finally you might have dealt with similarity. Those are some of the big topics. I can't guarantee that that's the types of questions that'll be on there, but those are the big focuses when it came to proofs, right? There were a lot of other proofs in there about circles and things. I can't guarantee for sure. I mean, no one's allowed to see the test, but it's going to be something that you took a lot of time to focus on. Well, in this case, let's see what they gave us. They told us that ABCD is an isosceles trapezoid, which is telling us what? Well, based on the picture, we can see that I shouldn't have said that because I said don't look at the picture, but you can tell what a shape is. It's a trapezoid. They did tell us that. So AB is parallel to DC, so those are your two bases. It's isosceles, and they're saying that those two sides, AD and BC, are congruent. Now, in a proof, you can't officially mark that and go with that until you say it, okay? They also told you that M is a midpoint of AB, and they're trying to get you to prove, and whenever I do a proof, I always mark in red or green or whatever it might be, what it is I'm trying to prove. So we're trying to prove that DM is congruent to CM. So if you're trying to prove something about DM and CM, you can't use that information within the proof. Well, you can bring DM and CM into the proof, but you can't actually use that statement that they are congruent till the very end. That's what we're trying to get to. All right, so let's look. Let's follow this flow chart. What they told us was that M is the midpoint. That was given, yes. What can you conclude from a midpoint? Well, you can conclude that the two segments are congruent, and that's what happened. AM is congruent to MB by definition of midpoint. Good. It also gave us an information that was an isosceles trapezoid, which means what can we conclude? Well, I marked it. I should have waited until I got to this statement, but that AD and BC are congruent, so that's good. And now we have this mystery block, and whatever's in this mystery block is going to somehow get us to prove that the triangles are congruent, okay? Again, as soon as you see triangles are congruent, I want 5 things to roll through your mind. Side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg, okay? Now we know hypotenuse leg is only going to work for a right triangle. These other ones could work for any other of the triangles. We're going to try to prove that they are congruent. Focus. I hit the button. I don't know what you want me to do. Technical. Hold on. Did I hit a button? Over here? Sorry about that. I just really wanted you to see that work. It's like in-your-face proof there, okay? Sorry about that. All right, are we okay now? All right. All right, so these are the 5 ways to prove triangles are congruent. We certainly can't use side, side, side because that's one of the pieces we're trying to find. So that one's gone. So we could use side, angle, side. We've got 2 sides. That's good. They gave us 2 sides, so we don't want angle, angle. We don't want angle, side, angle, or angle, angle, side. Side, angle, side. So how can we find the angle? Side, angle, side means the included angle, which would be angle A and angle B. Is there any reason that angle A and angle B would be congruent in an isosceles trapezoid? Let me think. What do you know about an isosceles triangle? Base angles are congruent. Remember I said a trapezoid is nothing more than a decapitated triangle? Well, guess what? Base angles are still congruent. There just happens to be 2 sets of them now. So angle A and angle B are congruent because base angles of an isosceles trapezoid are congruent. So that should be what our mystery value should be, and then we can prove the triangles are congruent by side, angle, side. So let's see. Segment AD is congruent to segment BC. Well, yes, we know that. They gave us that information. Duh, but that's not what goes in the missing block. The measure of angle MAD is congruent to the measure of MBC. Those are the 2 angles they want, but is it the right reason? The base angles in an isosceles trapezoid are congruent. There we go. There's our answer. And if we look at the other ones, AM and BM are congruent because of corresponding parts. No, those are congruent because of the midpoint, okay? And the last one, the angles, if lines are parallel, interior angles of the same side of a transversal or supplementary, these angles don't even lie on the right parallel lines, okay? So they're going to trick you up. There you go. Nice proof. All right, thank you. All right, we have time for one more. Let's look at number 7. It says if KLM is a rhombus, and the measure of angle KLM, this big angle right here, is 80, what is the measure of angle 1, the one that they have marked here? Well, there's a couple things you need to remember. First of all, what is a rhombus? A rhombus is a parallelogram with 3 more properties added onto it. Parallelogram. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. And what do you know about a rhombus? You know that diagonals are perpendicular. You know that all the sides are congruent. And what else do you know? Opposite angles are bisected, okay? You need to remember those 3 extra properties. So with those 3 properties in mind, if this big angle is 80, then these 2 little angles are 40. That was opposite angles are bisected. We also know this angle in the middle is a right angle. Why? Because diagonals are perpendicular. So if that's 40 and that's 90, What do you know about the sum of the measures of all the triangles? They should add up to 180. So 90 plus 40 is 130. Subtract out. We're left with 50. All done. All right, so there were some helpful hints to get you started on the geometry. I'm going to be back on Friday, and we're going to tackle some algebra and some more geometry just to make sure you're ready. And I hope you'll tune in and call in or email with your questions. All right, thank you very much. Have a good day. Okay.